Hello dear students, this is Dr. Saurabh sir's class. This is our contact number. Please feel free to call us and we will organize you very generic solutions of your doubts, and we will provide you the one-on-one sessions and the classes. And we are eagerly saying that we are going to launch a batch which will help you with mathematics and etc etc. So this question is from our TIFR GS 2025. So we are going to solve the question. Okay, so the question is telling us that let xn is equals to 1 minus 1 by root n whole to the power n and into e to the power n to the power 1 by 4. Which of the following statements is correct? So our option 1 is telling us that limit n tends to infinity, xn equals to 0, and the summation n equals to 1 to infinity, xn converges. Okay. Our B is telling us that limit n tends to infinity, xn is 0, but the summation n equals to 1 to infinity, xn diverges. Option C is telling us that limit n tends to infinity, xn exists but it is non-zero, and our option D is telling us that limit n tends to infinity, xn does not exist. So what can be done with this? So firstly we have to analyze all the things that we are going to rewrite the thing which is our xn is equals to 1 minus 1 by root over n into e to the power n to the power 1 by 4. Okay. So after that, what can be done with this? Okay. So firstly, I want to take our a n be 1 by root n. So as our n tends to infinity, our a n will go to 0. So we are going to use the logarithm, then we'll have what? Ln 1 minus a n whole to the power n will be n ln 1 minus a n. We are now only thinking about this part, only this part. Okay, so we are getting this thing. So after that, what can be done? Now for small a n, we approximate this thing. That means ln 1 minus a n. We can approximate this thing to what? To minus a n from the Taylor expansion of our ln of 1 minus x. As this is minus x and all, so we are taking only the first term. So that will be minus a n. Okay. So thus our ln of 1 minus a n whole to the power n will be a n into this. So that will be minus n a n, and that will be what? My a n is 1 by root over of n. So minus this thing will happen. So that is root over of 1 by n. Sorry, that will be root over of n. So now exponentiating both sides. So we will get what thing? Our 1 minus 1 by root n whole to the power n will go to this. Yeah. So now we are going to analyze the xn part. So our xn is whole thing. So our xn is 1 minus 1 by root n whole to the power n into e to the power n to the power this. So that e can be approximated as so n to the power 1 by 4 minus root n. Okay. So now asymptotics of we are going to think about the asymptotics of, yeah, sorry, that will be, yeah. So that the exponent e to n to the power 1 by 4 minus root n determines the behavior of xn. Observe that as our n tends to infinity, this thing will be n to the power 1 by 4 into 1 minus n to the power 1 by 4. So since our root n grows much faster than n to the power 1 by 4, so we can conclude that this thing will go to minus infinity as our n is going to infinity. So thus our e to the power, this thing will be go to what? So thus our e to the power whole the thing will go to 0. Then our limit of n tends to infinity, xn will be 0. So 0 is the correct answer of this question. So after that we are going, okay, so we are have to find the convergence or divergence of the series. Okay, so our limit is 0, we have got this thing. So now we are going to think about our series, that is summation of this thing. As our xn, the approximated value of xn is, sorry, that will be 1 by 4 minus root n, and the sequence xn approaches 0 very rapidly, exponentially fast. So however, the rate of decay depends on the dominant term e to the power n to the power 1 by 4 minus root n. So the exponential decay is sufficient to ensure that the series xn converges. So the correct option of this question will be my A, where the limit is my 0 and the series is convergent. Hope you understood the question, and again I am telling that we are going to organize a batch for you that will help you to understand mathematics and get a good grip in the logical thinking. And the number is 9836793076. We are Dr. Saurabh Sir's classes, and please feel free to call this on this number. Okay, thank you guys. Hope you understood. Thank you.